Now, we get to the next problem. It says, you on the graph below, calculate the x-axis density, da-da-da-da-da. Sketch the intensity of the interference pattern expected for that arrangement. So what you have to do on that one is that you have to, and again, I use the old school version that I learned. So you have M lambda L over D, right? So if you're clever, what are you going to start with M equaling?
No.
1. Okay? You know what the wavelength is. Now, is the L the 0.6 or the 2.5?
2.5.
That's the 2.5. That 0.6 has nothing to do with this story. Okay? It's there, but it isn't part of the story. So if you do this and you plug in that gap, which you're told that it's 0.2 meters separation, okay? If you do this, you get 0.3 meters. I don't know. So you're just going to let M equal 1. Everybody cool with how I got 0.3?
Yes.
Yes.
Okay. Now, this is how this is going to show up on this graph. So this is it's an odd thing. This is why I wanted to show you this, because it's a little bit weird, but until you kind of get a feel for it, and then it makes sense. So this is 0.1, 0.2, 0.3. 0.1 down there. So where are you going to have the most intense light? Right in the middle, right? That's where you're going to have your most intensity. Now, where is going to be the next most intense line?
Plus minus 0.3.
Plus or minus 0.3. So over here at 0.3, now, is it going to be as intense as it is in the middle?
No.
Oh, because it's more spread out. So that's going to be something like here and here. Now, will the intensity ever go to 0?
Yes.
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 Where? At half. So if this is 0.3 at 1.5, your intensity is going to go to, so this graph is going to go something like this. Okay? And keep going out like that. Okay? So what that 0.3 tells you is the distance to the next maximum. Now, on the back side, and I'm not going to have you do this. I just want to point this out as a difference. So on D it says, suppose the microwave wavelength is decreased by a factor of 3. So if I shrink the wavelength, what's going to happen to the distances between these maximums? It's going to become smaller because you're going to have a shorter wavelength. Now, what I won't ask you is on what's going to happen on E, but I just want to point this out, is that if it's a one opening, and again, this is not going to be on the test, it's the exact same calculation, but if it's a single opening, then that value tells you what it is to like the first minimum, okay, instead of the next maximum. So on E, and again, this is not, I'm not going to ask you this, but if it's a single slit experiment, it's the same equation. You're just going to go to what that number tells you is to the first minimum, not to the next maximum. Okay? Sometimes it get wonky and they throw that in on the AP test. That's the only reason I'm mentioning that. Do not work, E is not going to be on your test. At best, you're going to be able to have to work through B. That other problem is very similar to what we just did, okay? Basically, it's kind of an experiment. What are you going to do? Don't worry about 3E. So if you work through that, E is not going to be on the test. It's basically, do you understand how you could do this? And there's that. Okay, I'm done. Southeast, you're out.